everybody, and welcome to Build Meets World. Once again, it's our ability to bring information virtually to our community, the commercial and residential commercial construction market. Today's topic I'm very excited about bringing to everybody, as it's super relevant in many areas from a life safety perspective. And as you can see, it's something that we're going to be bringing a lot of more additional information to you as it relates to storm shelters and our Nudura insulated concrete forms, and our colleagues, Martin Clark, many of the other colleagues with Nudura, in a program that they're working with FEMA, so that we can provide these storm shelters in a way, to add to an existing building, existing residential area, and then of course provide that life safety aspect. And I thought it would be very important, as we're talking about storm shelters, to invite our guest on today, who is Andy. And Andy is coming to us from Wisconsin. So we haven't actually physically met, so I haven't gotten out into the world to work with him, but I did watch a presentation that he gave. Obviously, he works in the building industry with Intertek and gives presentations regularly. And I saw this specific presentation that I thought would be so relevant for us. So Andy, welcome to Build Meets World. Excited to have you on. I'm going to pass the reins over to you. So why don't you go ahead, explain yourself, your experience in the industry, and of course, your information that you have for us today.
Great, thanks, Marcy. I've been with Intertek since about 2015. As a real quick kind of primer for people who don't know, Intertek is a global assurance, testing, inspection, and certification company. So we've got 40,000 employees across 100 plus countries around the world. So truly global. So when I started with Intertek, it was on the testing side of things. I was originally managing a lab that, among other products, tested windstorm shelters, components, things like that. And then after a few years, moved into the evaluation services side of our business. So looking at certification listings and code compliance research reports, things like that for building products. And then most recently, now I've moved into a role managing the evaluation services team here in Middleton. So, over the past several years I've been with Intertek, I've gotten a lot of experience, on all sorts of different sides of testing and certification for the storm shelter components and full storm shelters. In terms of ICC 500, I've served on the Chapter 3 work group, which is design requirements, as well as the Chapter 8 work group, which is the testing requirements. So starting out with the last cycle where we developed ICC 500 in 2020, and then moving into this current cycle here where we're developing the 2023 version of ICC 500.
I was just going to ask you that, is it something recent? And I guess so, if it was, finalized in 2020 and you're working on a revision. So that's great. Great to hear that.
Yeah, so it's been all the way since 2008 was the first version.
Okay. Yeah. Good. Thanks for providing that clarity. But I love the fact that not only are you, involved with the testing, but obviously involved, with the creation or the revisions, I should say, of the standards. So that's great.
And yeah, it's really important, to talk about storm shelters. They themselves are so important because it all comes down to life safety. The tremendous devastation that hurricanes and tornadoes can bring and do bring, to the U.S. every single year. As a little bit of a primer, the hurricanes are classified by the Saffir-Simpson hurricane wind scale, which is based on maximum sustained wind speeds and ranges from Category 1 to Category 5. So there's a wonderful figure here that FEMA put out that shows kind of examples of this damage. You can see, if you get up to that Category 5 level where you're talking about completely destroyed buildings and areas that are uninhabitable for, weeks or months, possibly, can really just be, terrible devastation. And it's, not just one, small area that necessarily gets hit by this. You can see that it's, it's across pretty much the entire Atlantic seaboard and Gulf Coast. And then when a storm like this strikes, it's not even just, the lines that we see here on the map here, but the inset shows that, for this one particular hurricane, this is Hurricane Michael in 2018, you see this eye track on a map or something like that, but it actually had a 100-mile wide swath of hurricane level winds that cut through the Florida Panhandle. So you're really talking about tremendous, levels of devastation affecting, a very wide area. And then a little bit different is, on the tornado side of things, you have, certainly tremendous devastation, but, it's on a much smaller area, and it's a much smaller time scale as well. And so kind of, by necessity, essentially, we look at tornadoes in a different manner than we do look at hurricanes. With hurricanes, we were talking about a maximum sustained wind speed. But with a tornado, we just don't have the ability to measure that necessarily in the time and the location that it's occurring. And so we actually use the enhanced Fujita scale that ranges from EF0 to EF5 and looks at observed storm damage, and then tries to correlate that back to what we estimate the wind speed would have been during a storm event.
Okay, I didn't know that. I didn't realize that.
Yep, it's two different ways, to kind of look at this damage and really try and determine what happened there. So once again, here's another great figure from FEMA that shows the different levels of destruction that may be expected over the course of an EF0 all the way up to an EF5 tornado. And then whereas the hurricanes we were looking at, along the coast, obviously, tornadoes here, strike primarily in the center of the country. You can kind of see this is a historical track map from 1950 to 2018, looking at EF3, 4, and 5 tornadoes. And it's important to note that EF3, 4, and 5 tornadoes are only about 2%, 2.5% of all tornadoes that we see. The vast majority of them, about 97%, are EF0, 1, or 2 tornadoes, which don't even show up on this map. But yeah, it's a significant number of storm events that we see, and then like I said, mostly concentrated in the center of the country. So getting a little bit into ICC 500 and FEMA and things like that. So ICC 500 itself is the guidance document in the United States that oversees the design and construction of storm shelter. So it's an ANSI consensus standard that's put together by a committee. It's code referenced right now in the IBC, the IEBC, and the IRC. And then it breaks down storm shelters into 2 classifications. So you can have a residential storm shelter and you can have a community storm shelter. So a residential storm shelter is anything that serves a dwelling unit and has fewer than 16 people in the occupant capacity. A bit of a misnomer is people hear the word, community storm shelter, and they assume, oh, okay, that's a storm shelter that's going to be open to the public or something like that. And that can be true, but it's not necessarily true. Community storm shelter is just anything that's not a residential storm shelter. So it could be specific to a particular building, like say a hospital, a school, a 911 center, something like that might have a dedicated storm shelter just for those building occupants, or it could be open to the public for the community, or it could be a combination of both. So as we kind of touched on just a little bit ago, we're actually in the 3rd edition right now of ICC 500. So it's been in development for the last 20 years. So 2008 was the first version, and then there was a pretty substantial revision in 2014 and again 2020. And then we're currently working on the 2023 version, and our hope is that we'll be able to get that completed in time to get it referenced into the 2024 I-codes. So that's the goal we're going for.
Andy, do you think there's a specific reason why there's been, the need for changes that you could point to, and especially maybe the duration is that much closer between the 2020 and then obviously this current one you're working on?
Yeah. So I mean, essentially a lot of it is just, kind of recalibrating, so to speak, when we either get new data from, storm events, or we're observing items in the field that maybe aren't performing the way that we had hoped or something like that, or just, new science is coming about all the time. One of the major things is in 2014, and we'll touch a little bit on these class of things called impact predictive systems. So a door, a window, let's say, traditionally for the hurricane standards down in Florida and things like that, you test your largest item and it's assumed that anything smaller than that or anything stronger or stiffer is going to automatically do better. And so you just get granted. In 2014, we realized that, or leading up to the 2014 version, we realized that actually smaller, stiffer elements sometimes can fail in ways that we weren't necessarily predicting because of that stiffness. They just fail in a different manner. And so that was a major change that came in 2014. And then we just have additional items like that where we just keep getting more and more public consensus coming in, with ways to improve the standards, as well as reacting to what we're seeing out in the industry. So that was ICC 500. So that's put out by, like I said, ANSI consensus committee. So then on the FEMA side of things, they have two different publications: so publication 361 and publication 320, or P361 320. So P361 is not code referenced. It's not a consensus standard like we were talking about for ICC 500. It's actually specific funding criteria for if you want to use FEMA grant funds for your safe room. And so right now it's actually in its 4th edition, just came out in 2021. It specifically references the 2020 version of ICC 500, and it covers both community and residential storm shelters. So FEMA P320, on the other hand, is specifically just residentially focused. It takes all of those requirements that are in FEMA P361 and ICC 500, and it kind of concentrates it down to prescriptive plans and kind of a roadmap for how to go about actually getting a residential storm shelter in your own home. So it's specifically made for homeowners and contractors, things like that, to look at residential safe rooms. So it kind of throw around the word storm shelter and safe room, and a lot of times people kind of use these in very general terms, but they actually have very specific meanings as well. So a storm shelter is anything that complies with the ICC 500 standard. A safe room is actually the term that FEMA uses for anything that complies not only with the ICC 500 standard, but also with FEMA P361. So all the requirements in FEMA P361 are equivalent to or more stringent than ICC 500. So anytime that you've got a safe room, it's automatically going to be a storm shelter. But every time that you have a storm shelter, you don't necessarily have a safe room if it doesn't meet that extra level for the FEMA grant funds. And then finally, there's this kind of third classification called a best available refuge area. And so these are areas that don't actually comply with either ICC 500 or with FEMA P361. But the building designer has identified that this is the area that they believe to be the least susceptible to storm damage, and that they believe would have the greatest protection for life during one of these storm events. Unfortunately, though, because they don't, comply with ICC 500 or FEMA, requirements, they don't necessarily always provide that level of protection to building occupants like is hoped.
Is there a certain methodology from an enforcement of these, the ICC 500 or the FEMA? Obviously, FEMA, it's important if you're going to get the funding, right? So that's somewhat enforced and looked at. But if I was going to a storm shelter, is there a place where I could look to see that it says, is it noted somewhere that it's ICC 500?
Yeah. So there's two halves here. So A, it's a code requirement that anything that's going to be complying as a quote unquote storm shelter needs to comply with ICC 500. And then ICC 500 itself has labeling requirements. So absolutely, there should be a label, a placard, something like that inside the storm shelter that says not only does it comply with ICC 500, but it's going to tell you if it's a hurricane or a tornado storm shelter, because those are actually different requirements. It's going to tell you the maximum occupant capacity and some other items like that as well. So a lot goes into these, storm shelters and safe rooms, from the design side. So you need to consider things like rain loading. So tornado shelters just essentially need to be designed in accordance with the code. But for hurricane, obviously we have this expectation of far greater levels of rainfall. So you actually have to design a hurricane storm shelter for the 100-year 1 hour rainfall, plus a surcharge of 6 inches of water per hour on top of that to design. If you're looking at putting this in, for instance, here's, a garage floor unit, you need to consider roof live loads on there of a minimum 50 pounds per square foot for a hurricane or 100 pounds per square foot for a tornado shelter. And that's regardless of where this is going. But if it's going in a garage floor, like something like this, you need to worry about the wheel loads. If that car that's, there, were to come on top of the shelter, can the shelter take that loading? And then also you need to design these things for falling debris. So if you have a one-story shelter next to a higher building, something like that, you need to consider whether there's debris that could fall off the higher building and strike a lower shelter.
Is that because I'm sorry, because you're looking at, the buildings around you, is this something that has to be renewed? Like, so say I built one and then a huge building comes up next to me. Is that something that we need to kind of revisit on a regular basis, or is that up to me as the owner of the building?
Yeah, there's no specific requirements for that in ICC 500. ICC 500 is looking at, when this is being designed. Are there taller buildings next to you? Are there, a cell phone tower or a radio tower, something like that could possibly, fall down in a storm event and strike the shelter. So after it's built, if you were to, put up some large structure next to it, definitely it would be the sort of thing where the building owner would want to re-engage, an engineer and, evaluate whether or not the storm shelter roof or whatever aspect was still suitable for that new environment that it's in, essentially. Yeah, that's an excellent question. So another thing that often maybe gets overlooked is if you've got an underground storm shelter, if you've ever tried to, hold a ball underwater in the pool or something like that, the buoyancy force is going to drive it back up to the surface. And when you have a hurricane or something like that, you have incredibly high groundwater levels, and they can actually float these shelters up out of the ground. So that's definitely something that needs to be considered when designing these. And you'll actually have hold downs and anchoring systems and things like that that ensure that this doesn't happen. If it's in a flood hazard zone or flood surge hazard zone, you got to worry about flood loading, whether it be wave action on it or just the hydrostatic forces. And then probably the one of the most common things that people think about when they're talking about a hurricane or a tornado is wind loading. So ICC 500 has prescriptive maps for here's hurricane map for the Gulf Coast for the wind speeds that we need to design for. So these are above and beyond what the standard building code requires. And then here's a map for tornado wind speeds. What do those wind speeds need to be? And so the darker area in the center of the country there is the highest wind speed, which if you remember back to that map I had at the beginning talking about historical tracks of where these tornadoes have been, it's it overlays right on that 250 mile an hour high wind speed zone in the center of the country. And then probably the other major thing that people think about when you're thinking about a hurricane or a tornado or something like that is windborne debris. So there's a number of examples here of building elements that have become debris in the storm. So when we go to test these structures, we'll actually impact it with a nominal 2x4, whether it be either a 9-pound for a hurricane or a 15-pound for a tornado. And a lot of times I've had clients asking me, why is it that we're using a 2x4? That seems kind of silly. But you can when a house or a building is destroyed by a tornado, it becomes part of that storm. And so there's a lot of evidence after the fact of these storms that this is occurring, this sort of damage. And the final kind of major one is fire safety. After some of these storms, you have broken gas lines, things like that could lead to a fire event. Possibly you have some sort of an issue where egress from the shelter, it's a little bit more difficult than it was initially, because you've got debris, you've got things like that. And so fire safety in a community shelter is really an important consideration. And I mean, we could talk for hours about all the different requirements. But just suffice it to say that there's an awful lot that goes into these shelters, and rightly so. These are all about life safety and protecting human life, and so there's a lot that goes into making sure that that's going to be done correctly. So that's kind of the design side. As far as testing, there's a couple of different ways that we can go about testing these things. So you can either take a full storm shelter and try and test that And that's only, maybe perhaps that exact configuration that you've got. And a better way of doing that, a more efficient way, is you can take that storm shelter and you can say, okay, this roof design that I've got, I can test a representative sample of this roof. I've got this wall design, an ICF or whatever sort of, wall system. I can test a representative sample of that and then extrapolate from there how that's going to perform. And then, I can take a steel side hinge door that I'm using for this storm shelter, and I can test that door independently and then put that into a number of different types of shelters and know that it's going to perform as long as we are doing the testing in a representative manner that simulates the stiffness and the restraint that shelter is going to give to the component. So ICC 500 has a whole series of prescriptive impacts for different types of walls. I mentioned before something called an impact protective system. So that's anything that seals up a hole in your storm shelter envelope, whether it be a window, a door, a louver system, something like that. So these are given particular importance in ICC 500 and in our testing and design. So we're going to test not only the largest sample, but as I mentioned, we're going to test the smallest sample now too to see if that additional stiffness actually creates different failure mechanisms. And all this testing that we do, another thing where ICC 500 differs from the kind of previous some of the Florida hurricane stuff is that this is all incredibly assembly based and specific to those components. If you test a door with particular latching hardware and hinges, you can't just put in a different piece of latching hardware. Even if that second latching hardware was tested for ICC 500 Tornado, on a different assembly, the performance of these assemblies is so incredibly interrelated between all the components that you have to test those particular configurations and assemblies in order to get certification.
I was just gonna ask that. So like, I don't spend a lot of time in this area, and I'm very curious and wanting to. So for like in an NFPA 285 test, if we switch out a component, there's some engineering judgment you can do based. So in this case, what you're saying is, if something is changed out, we still need to understand how that would impact the component and then therefore the entire shelter as well.
Yep, absolutely. And there is, some engineering that can be done by the certification entity based on, incredibly similar, sets of hardware and things like that. And you can do evaluations to say there is a clear worst case out of these, a couple of different types of hinges or something like that, maybe, or this hinge is going to be worst case for a large assembly, but this hinge is going to be worst case for a small assembly, something along those lines. But it's far more limited. And it needs to, take considerable care in laying out those decisions and justifying any sort of substitution.
That's very important to understand that. What if I have my storm shelter and I've got my certification, everything's there, and all of a sudden somebody backs in and dents my door and I replace it? I got to make sure that I'm replacing it with the same type of door and hinges, right? I mean, that's critical, right? In order to keep it staying at that same level.
Yep, absolutely. And there, there's a possibility, a lot of these manufacturers of, say, a steel side hinge door or something like that, has approval for multiple latching hardwares and multiple hinges and things like that that work with their door. Okay. So it's possible that you could still find an alternative assembly that would meet that listing. But yeah, you're absolutely not saying, oh man, I backed into this, I'm running down to Home Depot to grab the first door and putting it back in, the opening. So
work with the manufacturer, work with the testing agency, make sure that your substitution is approved.
Absolutely. Yeah. So for testing, doors, things like that, we've got prescriptive impacts again, quite a few of them, in fact. And in 2020, we actually added overhead rolling steel doors and overhead sectional doors, what you might think of like a traditional garage door in your home. We added those to the standard so that they've got prescriptive impact locations and ways to test those so that we have uniformity across the industry for people who are trying to get these sort of things certified for a shelter. And then same thing for windows. We've got prescriptive impacts for the windows, and not only do you have to impact the glazing, but if you have mullions or other frame elements, within that window, you have to impact those as well to establish how those are going to perform under a pre-impact sort of scenario. And then finally, we've got pass-fail criteria. So what's it mean to pass ICC 500 for something that's being impacted? There's 4 main criteria here. So you've got perforation. Does the test missile, that 15-pound 2x4 that we're firing at this thing at 100 miles an hour, does that perforate the storm shelter envelope in any way? Is there dislodgement, disengagement, or spall of any part of the sample off the interior surface? Does it fly into the shelter and endanger, people who are going to be sitting inside that shelter? And then there's a maximum of a 3-inch permanent deformation. So, if this thing under impact or pressure or anything like that, moves 2 feet into the shelter, and could come into contact with somebody who's trying to shelter within that space, obviously that's a concern, and so that would be a fail. So that's the impact side, right? Which I said is kind of one of the major things people think about. But, the other one is the pressure, the wind pressure, and the atmospheric pressure too. You always hear people talk about tornadoes will suck the roof off of a house or something like that, from the pressure change. So we do a lot of different pressure testing. So there's static pressure testing, just a constant pressure for tornado. And then hurricane shelters actually also require cyclic pressure that actually kind of buffets back and forth for 9,000 cycles that we conduct after impact on a sample to see, is that going to stay in the opening? Is that going to continue to protect after not only it gets impacted by debris, but then it goes through this whole cyclic wind process for hours or a day or something like that. And if you're looking on a full shelter, we can apply these same sort of ideas. So you take your full shelter and you say, okay, I've got my prescriptive impacts for a wall or a roof system. I apply that to the shelter, then I turn the shelter around and I've got a door, so I can impact the door like I would any other door, and so on. And you're able to test the full shelter in the lab if it's something that's feasible from a size standpoint. Same thing with pressure there. We can on the left hand side here, draw a vacuum within the shelter and try and crush it like a can to see at what pressure does that fail. And then same thing on the right there, you can blow it up like a balloon and see when is this going to fail. And that gives you some information. You can tell that door, for instance, is going to perform based on that testing. But in a real world scenario, if you've got wind coming from the left side of a shelter, it's pushing in on the left wall and it's pulling out on the right wall. So it's actually going to try and tip this whole shelter over. And that's something that we don't have a way of, in the lab testing, short of, a giant wind tunnel or something like that. So there's always going to be some engineering that's required for these shelters, if you're talking about a full storm shelter, to ensure that it complies with all the different design requirements. So there's a lot that goes into these. And you not only have the design and the testing, but you've also got certification to ensure that these items meet all these requirements. You and I talked a little bit earlier about you walk into your shelter, you look at that placard that says, yep, this shelter is in compliance with ICC 500 and it's going to work. So there's a lot of different benefits and requirements for certification. So the first thing is any impact protective system, so a door, window, loop system, anything like that, is actually required by ICC 500 to be certified and to have a label on it from an authorized certification entity like Intertek or any others. As well as there are some requirements in ICC 500 about documentation and use of professional engineers, things like that, that can actually be waived if you have a certified storm shelter or a certified component system, wall system, door, whatever it is. And then also, on the less, technical side of things, it's that whole thing again. You walk into the shelter, you turn around, you look at, this placard, and you see something that says this complies, with ICC 500, and it's from a nationally recognized, company, and you've got, customer assurance there that, when people need this, they need it, right? So, people want to know that when they need to rely on something like this, it's going to be there for them. And so then that just really offers, manufacturers, the customer assurance and the market recognition of having that certified.
Yeah, the life safety aspect of it obviously renders it that much more important. It's incredible to see and hear, all the different things that need to be done for these tests. How often are you doing a full test versus more of a component test? I'm assuming a component test is probably more often.
Yeah, probably there is more commonly component level testing done for, I mean, one of the major items that you would think about would be, a hollow steel, side hinge door sort of system, overhead rolling, steel doors to protect openings, things like that, windows, louver systems, that sort of stuff is probably the most common, because then those can be installed in any storm shelter, right? That's properly engineered. Community storm shelter, you're talking about schools and fire stations and things like that. All these components can go into them. But then absolutely, there's still a process for, especially on the residential side, these standalone prefabricated storm shelters that are actually certified as a complete unit. So the market, I think, in the industry was driven primarily by the fact that those kind of components we talked about, doors, windows, louvers, are required to be certified, right? And so these, a standalone shelter in and of itself wasn't necessarily required by code to be certified, but the kind of interesting caveat there is the door on that shelter is required to be certified. And so that, a lot of times I think people have, a bit of a misconception there about whether or not certification is required. Because that door, or if you have a ventilation opening that's covered by a baffle, that baffle, technically speaking, has to be certified as an impact protective system. And at that point, if you have to certify your door and your louvers and things like that, a standalone prefabricated shelter, makes a lot of sense to certify those as well as part of the process. And it's, not a, I won't say that it's a quick process, right? Very few things in this world that are this important are going to be a quick process, but it's certainly a doable process, and it's a process that we work with clients every day on. And the general flow is start out, initiate with us, right? Call up one of our salespeople, right? We'll get a project engineer assigned immediately, look at the specific requirements for your product, component, a full shelter, whatever it is, and start working with you. Engineering, for a storm shelter, like I said, is almost always required to have, whether that be from a third-party PE, or you can work with Intertek as a team of PEs that will be able to do some of that engineering, or you might actually have that already in your file, when you come to us, and that's excellent. We hit the ground running, develop a test plan, and then Intertek has a whole series of accredited labs across the country that we can do this testing in numerous spots around the country. So if you're down in the Texas area, we've got a lab there that can do this testing. If you're over on the East Coast, we've got labs there that can do it. If you've got the Midwest, we've got labs. So work with one of our labs, get it tested. The engineers will actually look at your manufacturing quality system, because that's a major aspect here too, right? It's the maintenance of the certification and the maintenance of this level. So if you produce a shelter today and we test it, the public needs to know that shelter that's produced 5 years from now is going to perform the same way as the one we tested today that we say complies. And so that's the kind of final step of any certification program is maintenance and ongoing inspections and quality assurance. So
absolutely, yeah, just as we talked about, if the surrounding area changes, right, all of those factors come into play. Somebody damages something, we got to make sure we're getting it back to that certification level, so you feel safe as you should in the storm shelter.
Yeah, absolutely. Yeah, it's such an important industry and such an important product that it needs the due diligence and the ongoing care. So yeah, I mean, if anybody's got additional questions, anything like that, I definitely recognize ask people to reach out. They can certainly give me a call. Reach out to anyone at Intertek here, and we'll get involved with any questions or any assistance that we can do. We've got actually a wonderful website on the screen there. Also, if you just do any web search for Intertek Storm Shelter, it'll come up, and it's got a link to the webinar you were talking about that's available online. It's got a whole series of kind of frequently asked questions that really dive into some of this information. as well as links to the FEMA website, which has, huge, quantities of tremendous information. It's got the FEMA publications there for available for download. We also have links to the ICC 500 standard itself for people who are looking to get more information about that.
Yeah, lots of great information, and I love that you referenced the recorded presentation, of which I watched, that got us having this conversation is there.
Yeah.
Access as well. So downloadable slides, the ability to watch it on demand is great. So lots of great resources. Obviously, when it comes to something like this and a life safety aspect, we certainly encourage you to reach out to someone like Andy or one of his colleagues at Intertek for those additional questions you might have. Well, Andy, thanks once again. I would love to engage with you more as it relates to this type of topic. So I'm sure you'll hear from me again soon, but I absolutely want to thank you. Thank you for your time and attention today, and really look forward to hearing the additional questions that the people watching will have, and we'll certainly be reaching out to you with those questions.
Great. Thank you so much, Marcy, for having me on.
Thanks so much, and have a great rest of your day.